Next, we're going to move on to external validity, and this is where findings can be generalized or applied to others beyond the study group. So looking at information we have with our sample, moving on and saying that's true for a population. So it's very important when the treatment or intervention or program is expensive, controversial, or something like that. So we want to make sure that if it's an expensive intervention or program, and we want to make sure that what we found with the sample is valid for the population. We want to make sure that's real rock solid, because there's going to be a large investment to make that available at a larger scale. Or if it's something that's controversial, we don't want to take on that unnecessary controversy unless we're absolutely certain the treatment works with the sample and will work with the population. So just like with internal validity, there are threats to the external validity, and these include selection bias, reactive effects, repeated testing, multiple treatment interference, instrumentation, the Hawthorne effect, and selection interaction. So selection bias really means we're not doing random selection. We're not relying on randomization to select participants. So we're coming in with a different view of that. We're looking at volunteers, or we're looking at people that are already in place with certain characteristics of some sort. So an example of that would be, do recreation majors completing a leisure attitude survey in their research methods class accurately reflect the sentiments of undergrads on campus, right? So if we're looking at leisure attitudes, the reason it's selection bias is because we're selecting a group of people that we already know fit within a certain area and probably have a certain attitude related to that. The next we'll talk about is reactive effects. And this is when observation or response is recording in our environment, our lab, or wherever we're doing research does not actually happen in a natural setting. So a good example of that would be responses recorded inside a batting cage are not the same ones that we're going to get when someone's actually playing a game of softball or baseball, right? So you might be able to hit a lot of good hits in a batting cage, but when you get out into the real baseball game or softball game, the environment is different and the outcomes are different. The next one we'll talk about is multiple treatment interference, and this is when study participants are exposed to several different things at once. So we look at programs, treatments, interventions, or participation, whatever it may be. So they're doing several different things at once, and it's really difficult to understand how one program, one intervention, or one participation is really the reason that they're getting a certain outcome. So let's look at the example. A group of adjudicated youth participates in a 1-month high adventure camp. Which of the programs, bungee jumping, survival camping, or whitewater rafting, is responsible for noted changes in the mental and social health? So it's really hard to understand because number one, there's so many different things going on and they're kind of similar. It's going to be difficult to understand or really isolate one as being the more responsible one for the changes in the mental and social health. Next, we'll look at the Hawthorne effect. And this is when people consciously or unconsciously or subconsciously react to being tested. The act of being measured, the act of participating in the research, affects the outcome. And this is also called the guinea pig effect. So some employees opt to participate in a stress reduction seminar, right? All employees at the agency take a pre and post test to measure their perceived stress. Both stress reduction seminar participants and non-participants experienced decreased stress level over 3 months. So just the fact that they were being asked about their stress made the stress level goes down, even though some of them were not actually participating in the program. Again, we can look at a hierarchy of quantitative designs to maximize external validity. So we can look at, again, classic experimental design being the best one to maximize external validity. And then we move on down where there's no random selection of participants in the study that we're looking at. So let's look at an example with internal and external validity. Dr. J sets up a noontime exercise program in the office of a company. The program is offered for 2 months to find out if it benefits physical health of the participants. 30 people participate on average 3 times per week. 5 of these people are interviewed. All report they benefited from the program. Dr. J concludes that the program should be offered to all the company's 200 offices. So, Moving forward, if you question Dr. J's conclusion the noontime program is beneficial to participants' physical health, you are questioning the internal validity, right? So does the treatment actually affect the outcome? If you're questioning that, that's looking at internal validity. If you have a problem accepting Dr. J's advice to offer the program to all the offices in the company, you're questioning the external validity. So is this really going to affect the population, or was it just something with the sample? We're going to come back to generalizability. Sample generalizability. It's applicable when using non-experimental design and you want to generalize from sample to the population. So if the issue is sampling error, that's the difference between sample and population values, right? So sampling error, which is that difference between the sample and a population, you can decrease that when your population can be defined, your population is generally homogeneous or very similar, probability sampling is used, so that's random selection and the like, and your sample size is large. So let's go over that a little bit again. So you know exactly who your population is from the sample to the population. You can define it well. The population is homogeneous, so your sample that you pull out of that is going to be homogeneous as well. Probability sampling is used, so you're using true random sampling. And you're asking as many people to participate as possible, so your sample size is large. This is going to decrease the sampling error, which is going to increase your sample generalizability.